It's just really high quality.
I really like that one, but sometimes I'll like snack football. So honestly, do not be sharp.
I don't know. I love you. I like asking people for conversations. You already know you guys. I think that genuinely depends on.
I don't love that one.
No, same. I have one in my dad's office. You just put the pencil in. It just starts sounding like a wood grinder. There's a little beaver.
Oh, here we go.
So the next day, he always do his desk and she's like, you want to sharpen your pencil? She's like, no, I was told that industrial grade pencil. Sits it on his desk, and sharpens his pencil. I think he gets it.
Okay.
I saw someone make like a pencil.
Today, goal is build quiz number 3. So thinking about like what was module 3 about, what were we doing, how do you like demonstrate that you understand the last, I don't know, 2.5, 3 weeks of what we were doing since spring break, I guess.
Yeah.
I just like note cards. It's like that's enough. That's all you really need. It's like a bar napkin, note card.
Oh, no, David, those are just examples. Like we did on the homework where we find the forces, and then that would be mx doubled up.
First step, like half the note, like back half. What concepts were we dealing with?
Pendulum. Pendulum and space.
So it's like up the end. Now, big fan.
360.
I mean, yeah.
With the pendulum space, just
What if we talk about pendulum in 3 dimensional? It goes like this.
Idea, concepts, ideas, like what were we covering? What was module 3 about? Yeah, make that better.
Like movement, but with constraints.
Movement with constraints.
We were doing that last year. We gotta get more specific.
Yeah.
Rovers on the moon.
Moon rovers.
There's spring problems.
Rotating frame of reference. Polar coordinates are data. Rover on the moon.
you want to do a pendulum problem and go to pendulum coordinates?
What if we did a pendulum on the moon? Compare the motion of a pendulum on the moon to the identical pendulum on the Earth.
Okay. Yeah, we should yeah.
You do the same thing twice, you just change one number.
You change that G variable.
Yeah.
Oh yeah, like choosing coordinate frame.
Yeah.
What is that, like degrees of freedom?
If you double the mass of the pendulum, how is it?
I like that. How does this change the equation of motion? Pretty sure it's just a factor of yeah.
Well, but in one of the terms, it's square root x over.
Yeah, that's pretty much what it is. Like, choosing which was the best. Deriving it. Yeah.
Where even is the super? Oh no, yeah. I just wrote omega equals, and then I wrote omega with equation. So actually, yeah, we do it be hard to track. That, yeah.
How fast?
Cosine omega, cosine omega.
That's true.
Really, it's a good question. Yeah, it's just like, that's not, it's not.
Yeah, but
So,
yeah, I would agree the notion.
what's another thing like rotational mutation?
We did the rover on the moon.
So the rover on the moon now has suspension. Suspension system. Ooh, glorified strength. 100 unmarketable.
It seemed like some people were trying to say something like this of like creating an equation of motion, but not just like, yeah, just free motion, saying like, all right, this thing has to move, like pendulums. Pendulum has to move in a circle. It can do whatever it wants in that circle, but there's like that geometric constraint that it can't not be a circle, kind of like that. And then we were figuring out like, all right, if there's 1 degree of freedom, like we can track the angle and that tells us what it is. We can create an equation of motion to tell us what happens to that degree of freedom, something like that.
What's a simple device that would operate under the same principle?
Other than balloon?
Other than a balloon.
Yeah, balloon pendulum. Yeah, it comes up pretty often. I'm trying to, oh yeah, the other one is like,
There's a Disney movie about this. I know this one.
this one's kind of like a compound pendulum, but have you ever seen those like, like usually it has like some kind of grippers or something, but it goes along a track. And then even like cranes and like wrecking balls, like all those.
Wrecking ball would be good.
Wrecking ball, yeah. Like this one's a little different because it's like a rigid body that can't rotate, so that you have 2 strings keeping it.
Wait, could we use what we learned to like find the impact force of a wrecking ball?
Yeah, absolutely, yeah.
Wait, we hit 100 subscribers.
Oh, we have 100? Wow. 101, yeah. The big one, yeah, the big day.
Oh, yeah.
Wrecking ball could be good. What else?
What we want to find is to find like the force of the wrecking ball. Well, mass times acceleration.
What other concepts?
Well, we can decide that.
This was kind of the big one, but what else were we talking about here?
Rotating your reference frame.
The reference frame. So like mixed reference frames, like so a lot of engineering problems were just kind of like, all right, here's a Cartesian coordinate system, and by God, we're gonna fit everything into this square coordinate system. And you can do that. You can always force everything into that. But a lot of times it makes sense to have like some kind of rotating reference frame or a frame that like follows along. Like in that lunar rover problem, we talked about an inertial frame of reference where coordinate system 0 is the rover itself. Like the positions are always measured relative to whatever's moving. And it's kind of a cool frame. So like moving and rotating reference.
that same
reference frames, coordinate system. Yeah.
Kind of like what we did without like a good engineering skill was a linear approximation. I feel like
Linear approximation. Yeah.
It's easy, but also I feel like that's an essential skill.
We're not basing an entire problem on doing a singular linear approximation.
No. I'm saying like we do the whole problem and at the very end you're like, okay, let's linear.
Or subproblem.
No, like yeah, they just give you problem signs and cosines. Then you do linear approximation.
Yeah, but like linearization, that's a huge thing that comes up, like especially in control systems. There's anytime you have like big rotations, at least this is kind of what we figured out. Like if something's rotating, there's probably sines and cosines, right? Like it just sooner or later we're gonna have to deal with that. Those are all nonlinear, but we can say like, all right, for the most part, let's assume that it's linear over this small range. And you can do a lot of great like PID controls, even though you're approximating like a nonlinear system with a linear system. So it even works for, have you ever seen an inverted pendulum? Or actually, I know you have, but yeah, so a pendulum that is upside down. So another example of that would be, I lost it.
I guess you haven't mentioned those things.
Oh.
Yeah, I have. That's fun.
That does sound like a fun device to have. It is a fun device. It's a good conversation.
Except they're not really bring around with you. Hey, you can
How many beats per minute does it hit?
whatever you want.
Have you seen those like one-wheel skateboards or hoverboards?
2016 type.
Yeah, those are all, like the control system for that is an inverted pendulum. So it's an unstable pendulum because you are the mass at the top of the pendulum, and the more you lean forward, the faster the thing has to go to keep you from falling over. And it's all based on the work that we did with saying like, okay, here's a pendulum, can we model its motion? And if you can, then you can control it. And that's kind of cool. So we're doing like all the work to set up how do we predict motion. And then the next step, if you want to get like deeper into dynamics, is like robotics and control theory and all of that. But by that point, like everything just becomes like an abstract, like giant Laplace transform block. Have you seen Laplace transforms yet?
Yes.
Yeah. Okay. Yeah. Oh yeah. Yeah. So.
I got it. Laplace transform machine.
Oh, you'll get it.
We'll get to it.
Oh, you'll get it.
That's what I'm doing today.
It's on my exam today.
It's on your exam today if you don't know what.
Yeah, so if you're riding a hoverboard or a one-wheel skateboard, you're basically a little pendulum that's leaning forward.
You can transform a goofy odd function into something you can actually
Yeah.
solve. I got it.
I know the form.
Oh, it's a great sign.
Sorry, I got distracted. All this stuff is like fun and cool. What other concepts, what else did we cover everything? Done? That was, yeah. Man, we could have saved a lot of time if we just did this first, right? Just remember 3 things. I'm just joking. Like, we put in a lot of work to get to that summary. Yeah, but. Okay, so. All right, now, what are we doing for quiz 3? So you can flip over like note card. What would be something where you can demonstrate? So I'll keep track of quiz 3 here, but I'll leave the notes up from, oh, too many pages. How many pages do I have here? All right, a lot of pages. All right, I'll leave up what concepts we started with, and then you can come up with what ideas.
Hold on. Mike, you can't see anything, but
again?
No, it's not about athletic disorders.
Okay.
Sure.
Pension is bringing.
Web slinging hero.
And get a speed you swing around with.
Okay, are you assuming like constant?
Yeah, like, assuming you can stay at a constant speed.
Oh, okay. Does it matter?
Yeah.
So if you're spinning it, does it matter if it's increasing speed? Is it gonna change what tension you have?
It's accelerating.
You think so?
Actually, I can do it.
Yeah.
The tangential speed.
Well, like,
It's not a downswing.
so when we had those inertial,
I love that. He's so
inertial coordinates,
Yeah,
and
he did a great job with that.
speed.
No, I mean, like, just
And then other terms, like e squared for the two acceleration terms.
He's on me.
Yeah. So, like, as you're spinning it, for the most part, the tension is always
He's the bad
v
guy. He's
squared.
talking to codes like, why are Omni-Man and Steve fighting?
Mhm.
The drumming one? Oh, I think
Yeah.
Like the.
Oh, yeah, like if you're in a
Yeah,
movie,
yeah. No,
Sometimes if you're spinning fast enough, like if you're doing more than 6 rotations per second, something like that. Sometimes gravity, by the time it has an effect, like you're already going.
I've said too many incriminating
So some spinning systems are moving fast enough.
Idiot.
Just get more gravity anyway.
It's just an idiot.
Oh, yeah.
That's what I think. So it's like constraints, like only going this
I'm not
way.
engaged. I'm happy.
So like hold it around it. You know, like,
Yeah.
we have to drop this basket of water.
Yeah.
Yeah.
Can you, does it get like, are there?
I mean, you do have one like there.
We're friends. Plus, I don't even know if friends. She just tolerates my
Yeah.
Are you coming along with me?
Are you coming along?
No, I actually had to go to my advisor.
I have to go for it. It's not.
I'm just inviting you. Yeah. I invited you both to my advisor. That's okay. We're just gonna make a lot of other, Mormons and stuff. It's fine. I don't care. I'll rip on the Mormons. What is it? Take me to Utah.
Where it was like you swing it around and then it was like,
They don't have jurisdiction outside Utah, yeah.
I don't know if it's the
Spider-Man swinging back and forth.
I had one.
Yeah.
It was like, you spin it, it was like a plastic thing that you just bought.
I guess like, what is a good follow? Like, how high does Spider-Man have to swing from in order to kick Dr. Octopus in places or something? I don't know.
Yeah.
This could use some like more development. R&D. Spider-Man swing back and forth with I'm saying you and Peter Griffin are also there. This is Fortnite.
Oh.
Yeah. Why do you drink so? He's like all depressed because he accomplished all his goals and he took over Metropolis. Drinking food. Why do you drink? And then he walks in. I can quote like 90% of the Tesla movie, like the Lego movie, Megamind, Star movies.
Get a life, bro.
That's wild. I'm never gonna see that. I'm actually taking my brother this weekend because my parents are going on Saturday morning. My brother's like, let's just catch a Saturday morning show that we don't stream. He's not right. No, we're going to like the 9 a.m. show. Yeah, I saw that. Dude, the media announcements were really great. Dude, we're getting Silk Songs. We're getting Delta Green chapters 3 and 4. Nobody ever thought this would be
Yeah, more in the video again.
I've saved up enough money so I can afford at least 3 Nintendo Switch 2 games.
At least.
No, I'm just kidding.
That's crazy.
No. But yeah.
I do like that trolley problem.
Trolley problem?
No, like the
I love this trolley problem. Yeah, when you pull the lever. No, yeah. Have you seen like all the parodies of the trolley?
There's a website, I'll put it up on my computer. There's a website that has, Mike, this will be good to review.
It's more of like Netflix thing. It is utilitarian. The thing is, though, there's no.
No, if you're an enemy, no, sorry, you're on this. No, it's hold the track lever in the middle.
It's gonna derail
the
stuff.
Yeah. So.
This is why you should major in engineering and not. No. This is why you major in engineering, not flying. Plus, they just spend too much time thinking about who to kill. Engineering majors are like, oh. If I switch it after the first set of wheels goes over, it can drift over both tracks.
Oh yeah, I've seen that before. I think this is how it is.
Oh,
Yes,
Marshall
yes,
posted
yes.
it.
So it's we're just gonna pull over.
Oh my gosh, I love these.
Playing 5 versus 4.
No, and there'll be one where it like replaces the trolley with 6 of this, rolling the boulder.
Oh no, then your leg savings will be destroyed.
Do nothing.
Dude,
I want to see how you do that.
43%.
No, my bank account.
Or you could choice how to go with 5. Or you.
I look, you want to.
Yeah,
38% of people agree.
Yeah.
another 30.
But there is no copy of the Mona
You
Lisa.
don't even know what the original copy of the Mona Lisa is. No, the original version. That's not the one to the movie. We can put like that's a pretty good one.
Oh no, Charlie is adding to it.
I don't think we'll just like if you can pump it, you can buy it. Oh wait, no, I meant to run up the rich.
Oh.
Never mind.
So Charlie is adding to the final lobster.
Yeah, eating the lobster was just.
Yes.
Yeah, you know they eat the lobsters after.
Oh no, Charlie is adding to the 5 people. Version 1 but doesn't need to buy it.
It doesn't matter, pull the lever.
Yeah.
Oh no, Charlie is adding to the
Sells to the track. Yeah, but they have it coming through. Do nothing.
Yeah, so I did and so
The lever speeds up.
yeah,
pull the lever.
and it was going really well until
a minor inconvenience.
like someone had
Charlie is adding to the 1.
Yeah.
like they literally just
Do nothing.
like I couldn't even
I need
so they just told me to try to
Is your best friend?
Best friend is not Zion.
yeah,
He's got glasses.
Oh no, when you forgot your glasses.
Yeah. I don't know, I wouldn't be able to see the letter, so I'd probably do nothing if I used and they have a different
For one first cousin and 3 second cousins.
I love my second cousins, actually so much more than my first cousins.
You see, there's 14 first cousins.
There's 2 first cousins and 14 second cousins.
Well, I'm saying like my family has like a total of like for my grandmother to have 14 siblings. So that gives me like 12.
There's a U or 5.
Wait, the clones are illegitimate.
They're atrocities.
50%.
Oh, well, I love the example. Hypertension I mean, if you're talking about like your expected value, you want to pull the lever.
Yeah, like a yo-yo, so like it could spin around like the ball, or it could like go down up, or like forward.
Okay.
But I didn't know like I didn't know how to really if like the ball was moving.
Oh
But
no.
like I didn't know if like that would really from there like for it and like taking it with like a hand.
That one. Ah, mandate board beyond my comprehension. No longer beyond my comprehension. It has a constraint. I don't know. Pull the lever.
To destroy one.
More is moving faster it spins. But I don't know.
It's wrong.
Rigid. It's just
Yeah.
it doesn't matter. An elastic band. That's a dumb thing.
That's what it kind of is. It's like a band like going back and forth and like
Yeah.
You're incredible.
Oh my gosh, this is like Dark Souls. Bouncing pendulum. Yeah. This is like
It really is
if you
anything.
rekindle the flame. You kind of want to crank it bounce out. Pull the lever after the first axle goes over.
Yeah.
We got stuck.
Yeah. I have a philosophy exam. We're helping each other.
They get more ridiculous as you go.
Oh, okay. Good. So then, yeah, you gotta pull the lever. Get rid of that system, right?
Yeah.
See, they think about it.
Yeah, we're studying utilitarian at like the
Yeah.
Very cool.
Yeah.
There's more, there's like that.
Wait, Professor, give me a Spider-Man swing from a web, pendulum motion.
Yep, that's true.
On Spidey.
Oh man.
Did you guys ever watch the Spider-Man Disney XD show? Spider-Man.
Yeah, definitely.
That's kind of good. And then there's that scene with Sandman. You always know where I am. He has some kind of Spidey sense. Oh, it's funny you mention that.
Oh my god, what is going on? It's like, it keeps giving me like 10 new pages.
Was that what Scooby-Doo? They had Scooby-Doo. I used to go, dude, my town used to have a Blockbuster, believe it or not, and I would go to Scooby-Doo.
Here we go.
Chased by a ghoul for a Scooby snack.
Oh, I saw a hot take. How come it's always red and nasty?
Yes,
It's
right. You
from
do actual research. Shaggy and Scooby, you kind of run around and do whatever. Daphne and I are going to check out the bedroom of the ghost.
So we were just looking at like what happens if you throw something that's attached on an elastic band.
like a rubber band.
Yeah, yeah.
Or a bungee cord.
And like basically, I mean, we did. It wasn't like
Oh, yo-yo, grappling hook problem.
Not yo-yo, but like the other thing.
Oh, a yo-yo. No. Wait, Adam's on something with yo-yos.
or the yo-yo. Yo-yo's kind of cool because like as it moves down, that
Does the moment decrease? That's not what this is. But it, yes.
like the height of the yo-yo, like as it's moving down, theta, I guess theta, not so much theta dot, but as you unroll a yo-yo, the further it goes, the more it has to rotate. So the faster it falls, the faster it spins. Until it gets to the bottom, then it depends on what kind of yo-yo you have, but some of them re-spool back up. The cool ones like You stay on the floor, you can walk the dog, you can do that. Yeah. 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 Yeah, make the Eiffel Tower. That was always or the cradle. I guess that's what I did. Yeah. Yep.
That is a good party trick right there.
Yeah, so yo-yo's kind of a cool one. Like as it's falling down, we have like rotational, like the main thing that's slowing it down is its moment of inertia. Like that's how the yo-yo is kind of working. And then we had is the idea of a surfer, like surfer. I don't know what kind of what you were thinking for like surfing. Well, like there's so one thing that I don't know if I covered this or like talked about it, but like everything can be modeled as a spring. Like if you're pushing on the floor has to deflect. So you applied a force, it deflected. When you unload, now you have a spring. And you can always say that it's a linear spring, even though there's usually some kind of linear part and then like nonlinear parts. So if you think about like a surfer trying to sit still, like it's always bobbing. Where does the bobbing come from? Maybe the waves, but even if you're just on, have you ever been on like a stand-up paddleboard on a lake?
Not for more than like 3 seconds.
But even there, it's bobbing. Do you know why it bobs? Yeah, so let's look at like, I'm gonna do like, oh my god, give me back my,
You go down on it and you just put a certain amount of water, so you're trying to...
It's like, there we go. So let's assume we have like
Windless,
frictionless indoors in a vacuum. Okay, you displace water, so it forces it down, but then it's buoyant, so it goes back up.
Yeah. So basically you have a spring made of buoyancy force, because the more you push the board down, the more force you have, which pushes you back up. But now the less buoyancy force you have, and it pushes you back down. And there's actually like my dad was telling me, coming into San Francisco Bay on a submarine, there's like, if you go too slow, you're okay. If you go too fast, you're a little dangerous, but still okay. But there's a natural frequency of your buoyancy force going through the waves in San Francisco Bay that's just gonna like knock your teeth out as you're like coming through these waves where you're slamming, you're at like the waves are at the same frequency as your natural frequency of just bobbing, and it's just going to get bigger and bigger and bigger until, yeah. I mean, at some point it's not going to throw you up and out of the water, but it gets worse. It kind of looks like a bird.
You ever push a boogie board underwater and then it like actually rockets out? You know what I'm talking about? Yeah. You try to stand on it and push it underwater.
Where it's like density of the water times gravity times the area of your board times delta x, like how much you push the board down. But yeah, anyway. Sorry, what else were we looking at? Spider-Man?
Spider-Man, pendulum like. So we got Spidey. Who should he be fighting? Spidey is inner battle. What if he wants to? I think he has more important things to do.
He's fighting Stiltman.
Who? Oh, still man. How do I know?
So Spider-Man swinging. What is this one?
Pendulum.
Like basically pendulum motion, right? Then I know we were talking about like other stuff. What else did I miss? Are we out of? No, we still have time. All right, cool. What else? Oh, and then I think there were one or two thinking about like inertial, like you were talking about like inertial reference frame, like something moving on a string, like tension in the string, which also like could be similar, like Spider-Man kind of question, right? Like if Spider-Man's swinging, like how fast can he swing? Or the opposite question of like, if he's, how strong is that web? Because that's usually like the main thing. It's like 10 times stronger than steel, or wow, this is the strong webbing, kid. Version 3.0 is some. There's always like some kind of like something about Spider-Man's webbing that's pretty impressive.
I don't want to see a spider that can make steel be.
Stop the train after all.
He did stop.
Yeah. And same thing. Usually like Spider-Man's got like like got the boulder swinging it around in a circle, right?
Oh, that's exactly. I was thinking hammer throw.
Or hammer throw, yeah.
With not looking near hammer from a distance. Hammer throw is really cool to watch.
What are we thinking? What feels like? Oh, I guess the other thing. All right, well, yo-yo was one thing where we had like some of the moments is I times theta double dot. That was one thing that we didn't like directly use in some of the problems that we were talking about, but it's like one other source of where we can get equations of motion.
What's changing as it goes down, right? Because the force, I guess, being applied to a string, but the radius of like how far the string is out from the yo-yo decreases as it goes down. Did that make any sense? Probably
Yeah.
not.
Yeah, does it decrease by a noticeable amount? That's what I'm trying to think of. Maybe.
Make an approximation.
We're gonna make an approximation that it doesn't yet.
Yeah.
It was just food for thought.
Yeah.
A simple turkey sandwich for thought.
Because, I mean, like if you have like thick coil, then yeah, every time you unwind a little bit, now it keeps getting closer and closer. Yeah, but I was thinking more that we could use this as the main approximation, is that the more it moves down, the more it rotates. Similar to rolling. Like if you move along a surface and you're rolling without slipping, the further you move, the more you rotate. The faster you move, the faster you rotate. That was my thought for that one. That's my like first approximation for yo-yo motion. What are we thinking? Some kind of like identify a spring and then create an equation motion? Or
And then linear approximation test.
linearize?
Just because I said it doesn't mean it's gonna be. Because linear approximation is important right now.
It makes us
Yeah, that's the point. We make approximations. Assume laminar flow, assume frictionless surface, assume isentropic process. It's all about that. That's the engineering grind.
What are we thinking? Rotating reference frames, inertial? Like where do you want to go?
The yo-yo one could be hard because it covers stuff we didn't talk about as much.
Yeah.
I don't know.
Yeah.
I still don't fully understand.
Yeah, it would be. It's not like impossible, but I think you could do it, but it might be like a challenge to kind of reframe what we were talking about. Spinning stuff or spinning, like spinning springs. Do you know what? Yeah. Do you know what kind of system uses like a spinning spring?
Do you like watch movies?
Sorry?
That'd be awesome. We can just do it.
Like a spring that, I mean, it's used in, you can always say like,
I've heard of that, there's some application, I don't remember what it was.
Thank you for contributing that.
so like if you have this thing spinning around, like why would you?
Train the astronauts.
Uh,
No, it's not.
No, it's
that one's like, usually you try to make it rigid so that the astronauts don't, they're not like stretching into the wall and,
I mean, clutches
Yeah.
have that, but they're not exact, like, direct.
clutches, yeah. So like governors, yeah. So governors, and like a continuously variable transmission, like all of them have like little weights and springs so that the faster you spin, the more it opens up.
like the more resistance in this.
Well, like the main thing is like, yeah, you can have something that like opens up and closes. Yeah.
What's the device on motors where it's two contacts and has a spin, so they separate? I had it at home.
Like the old steampunk one is yeah. This is like the
As it spins the ball, and
yeah,
fly farther apart.
yeah. So you can use it.
Pull on something.
Wait, what's spinning?
The axle in the middle is spinning.
Oh,
The ball's on the
So those
outside.
two balls are spinning around in a circle, and the faster. So it was used in steam governors. So like, if you're creating a lot of steam, they start like spinning really fast, and they move up and start closing the thing, and then as they settle down, now it opens it back up. So it was an analog control system. So you could change the length of them, or like put different. The masses didn't make a huge difference, but for the most part, the length, like how far out the masses were, that changed. Because it's basically a pendulum spinning in a circle that governs your solution. Yeah, or like carnival rides where you're like sitting in a chair and starts spinning, and your chair starts swinging out. You're on a pendulum. You're on a pendulum, but you have a moving reference frame, so now you have a different, like, steady state angle, right? Like it's not theta equals 0, it's theta equals, I don't know, 5 degrees, 10 degrees, 45 if you're really like flying off the sides. Yeah, what would, I mean, I can jump into this, but nobody suggested like spinning. Well, there were ideas of like spinning stuff, but yeah, but I don't want to jump into it. What are we thinking? How do we feel? What are we ready for?
if you were to put like something like that on the quiz, would you give us like useful hints and stuff?
This one, I mean, for the most part, like, we need a free body diagram. So we could say we know that there's some k delta x, some kind of force that forces it to go in a circle, like a normal, and that's it. Like those are the main forces that we have, and all that's equal to our kinetic diagram.
Yeah, what's the normal force? So, whatever.
Yeah. So
It's
like
not contact.
if you put the spring, if you just imagine you put it on a frictionless plate and then you start spinning the plate, the spring would just sit there and do nothing. So instead you have it in a track, and the track forces it to move in a circle.
Okay.
Yeah. Or same thing with like carnival pendulum. It's like the pendulum is attached to something, and when you start moving it, now the whole thing is rotating. So there's something forcing it to move in a circle, and that circular motion is creating now our like centrifugal force, right? Centrifugal force is real. Yeah, and for the most part, we only have acceleration like either away or towards the center of our little governor plate.
Why is it away?
It depends. At least the way that I would say this is like my y prime. That's my x prime. So if I want to say x is my x coordinate system and it always follows the track, then positive acceleration is saying that it's moving away from the origin.
It's just like the other one we did though. We use a step function. It'll come back, right?
A step function? Oh, for like friction?
Use a spring on a ramp.
Yeah, the friction direction.
Yeah. So usually friction.
There's no friction, but isn't the block going to start moving the other direction after it reaches the end?
Yeah, but it'll be like. So if we're calling,
In the opposite direction.
if we're saying that this is delta x, like some x minus L, then we have like mx double dot equals negative k x minus L0, and we're back to a spring.
I guess what I'm saying is like the kinetic diagram would change, right?
Yeah,
Like that
because
arrow, like,
what else are we
arrow would grow in
missing?
magnitude, and then it would go back, and then the opposite direction.
Yeah, yeah,
Right? Because like the spring goes all the way up, and then once it's all the way up, it gets pulled back, so it's accelerating in the opposite direction.
yeah. So what else are we missing with this like x double dot here?
Not the normal.
Because it's not, it should be different, right? It shouldn't just be a linear spring.
Wait, I totally
Oh, all right. I don't mean to. Oh my God.
No,
Give me my
okay.
pen.
You said something's missing.
Yeah. Yeah.
Oh.
So if we have that x double dot, we also have to say minus r. Yeah, like theta dot squared.
Wait, where do you get that equation?
So if you're using a rotating cylindrical frame, it's always r double dot minus r theta dot squared. That's my acceleration.
It's just one of those given formulas, right?
Yeah.
Okay.
So then I also have plus mr theta dot squared. So that's, at least if I take it, move it over to the other side and say, there's both the spring force and now I'm calling it like centrifugal force by throwing it over there.
I don't understand. Why are we combining mx double dot r theta dot?
How to combine them?
Yeah, they're like two different coordinate systems. Why are we like combining them?
Oh, well, x in this case is r.
Okay.
Yeah.
Oh, okay. So that's the same as r double dot minus r theta dot.
Yeah.
That's
Yep.
like a given equation.
Yeah. Yep.
Okay.
Yeah, like I could have written it as like k delta r and then m r double dot. That would have been probably better. Yeah. But all right. Oh, we're at time. What do we think? Like pendulums, spinning stuff, spring stuff. Which? Let the TA. Oh well, I'll build it based on these notes, and then yeah.
Spinning with the spring, I feel like that.
Spinning with a spring, like adding. Yeah, main thing there is like you add that, there's a centrifugal force because we have a rotating reference frame, but it's still like a spring and a mass kind of problem. That was what we were just talking about, yeah. So things that we could do like from here is like, usually the governor is assuming some kind of steady state. So like what is, when A is 0, now mr theta dot squared equals kx minus L0. And that's, yeah. Or, yeah, x, sorry, that would be like an x. Yeah, something like that. Cool, all right. Yeah, in this case, x is radius. It's just, I was drawing like an x prime where the x-axis is spinning. Yeah. Cool. Thanks. Have a great weekend.
I need to find my sock. I lost 2 different socks yesterday.
Skill issue?
After doing my laundry. I don't know how.
Conservation matters.